So today we are going to start different types of proofs. So we're going to talk about angle, side, angle, and we're going to talk about also angle, angle, side, and then a hypotenuse and a leg. So remember I did tell you that there were going to be different ways that you can prove things. So we're just going to kind of build upon how to prove congruency. So we're going to start today with angle, side, angle. Okay. And I double checked. I think that hopefully the worksheets that we're going to do are in Canvas for you. There we go. Okay. So angle, side, angle. So if two angles in the included side, so if two angles and the included side of one triangle are congruent, to two angles and the included side of another triangle then the triangles are congruent. Okay, we shorten this one to ASA, sorry. Angle, side, angle. Okay, so what I mean by that is I have two triangles here. Try to draw them good. So I've got A, B, C, D, E, and F. So I have my two triangles. Then I know that angle A is going to be congruent to angle B. So if angle A is congruent to angle D, okay, side AB is congruent to side DE, and angle B is congruent to angle E. Okay, then we can say that the triangles are congruent. So then triangle ABC is congruent to triangle DE and F. Okay? All right. So let's look at some proofs here. All right. So SQ bisects. Okay. So SQ bisects RQ and T. So SQ is going to bisect angle RQ and T. Oh, and let's do and RS and T. So that is given to me. All right, so SQ right here is going to bisect RQ and T and RS and T. So a bisector means what? When it bisects, then I'm going to create two congruent angles there, two congruent angles here. So that means that angle R, Q, and S, so angle R, Q, and S is going to be congruent to angle T, Q, and S. You see that? Okay, that's by the definition of a bisector. Okay. Also what? R, S, and Q is going to be congruent to T, S, and Q. So angle R, S, and Q is going to be congruent to angle T, S, and Q, also by the definition of a bisector. Okay, so those two, so I've got two angles right here. Well, now what do I have? They share a common side. So that means, I'm going to put two little hashes there, but that means that QS and SQ right there, those are the same measures. So that means that by the reflexive property, QS is going to be congruent to QS. So what do I have now? Okay, I have an angle, side, and an angle. So that means that triangle Q, R, and S is going to be congruent to angle Q, T, and S. Okay, by angle, side, angle. Because I have an angle, and I have an included side in between there. All right, y'all try to do number 2 for me. So y'all try to do number 2. Okay, so if JK is going to be parallel to LM, so these two things are parallel to each other. So JK is going to be parallel to LM. And LJ, let's do two lines here. So LJ is going to be parallel to KM. That's given. Okay, so if these two lines are parallel, so what does that mean about that angle K and angle L inside there? Sorry. They're wrong. So J, K, and L, and M, L, and K. Those are going to be congruent, right? So angle J, K, and L is going to be congruent to angle M, L, and K. Okay? That's alternate interior. Sorry. I have to think for a second. Okay, so then I've got these two are going to be parallel, right? So that means this angle here, so J, L, and K is going to be congruent down here, right? To M, K, and L. So angle J, L, and K is going to be congruent to angle M, K, and L. That's also by the alternate interior. Okay, so if those two, so I've got an angle that are congruent, I also have another angle that are congruent. Well, what's congruent right there? So that that LK is going to be congruent on both sides. Okay, it's the same measure. Both of those sides are the same measure by the reflexive property. Okay, and what then does that mean? That means I have an angle, side, angle, and the corresponding angle, side, angle are going to be congruent. So that now means that triangle J, K, and L. Okay, so J, K, and L is going to be congruent to M, L, and K by angle, side, angle. Okay? Alright, so y'all take a minute and try to do number 3 for me. Okay, so triangle or angle BA and C, so BA and C is going to be congruent to DE and C. So angle BA and C is going to be congruent to angle DE and C. C is the midpoint of AE, so that means that what? Those two sides are going to be congruent there. Okay, so if that is the midpoint, then that means that AC is going to be congruent to EC. Alright, so here that means this is vertical angle there, so B, C, and A is going to be congruent to that D, C, and E. I guess I could say that, so B, C, and A. So angle B, C, and A is going to be congruent to angle D, C, and E. Instead of calling it just angle C both ways, but those are going to be congruent. And why are those congruent? The vertical angles to each other. So, vertical angles. Okay, so now that means I have an angle, side, angle, angle, side, angle. So that means that my triangle A, B, and C, so triangle A, B, and C is going to be congruent to triangle E, D, and C. Okay? All right, so we have another way to prove, so this is our second one for today. It's angle, angle, side. Okay, we call that angle, angle, side. All right, so if two angles and a non-included side are congruent, to two angles and a non-included side. That just means it's not in between the two angles that are congruent of another triangle. Okay, then the triangles are congruent. Okay, so what does that mean? So I'm going to draw my two triangles again. So A, B, C, D, E, and F. So what does that mean? That means if angle A is congruent to angle D, okay, angle B is congruent to angle E, All right, now here is the kicker. So now I've got to have a side here. So now it's not going to be this side AB because that would be angle, side, angle. So it's going to be the side BC and the side EF. Okay, so it has to go angle, angle, and a side. So if then side BC is congruent to side EF, okay, then, okay, triangle ABC is congruent to triangle DE and F by the angle, angle, side theorem there. Okay? Alright, so let's do some examples of that. Alrighty, so let's look at this one here. So, given that angle ABC, so angle ABC is congruent to angle C, E, and D. So that is given, so angle ABC is congruent to angle C, E, and D. So that is given. Okay, and side AB is parallel to side CE. So these two sides are parallel. So AB is parallel to CE. All right, and also C is the midpoint. So, oops, sorry. I'm getting, my brain is thinking faster than I can write. Okay, so it's the midpoint of AD, so that's also given to me. So what does that mean when it's the midpoint? Then that means that these two sides are going to be congruent there. So side AC is going to be congruent to side CD. All right, so if this angle and this angle, or this side and this side are parallel, so then what does that mean about this angle here, this angle A and this angle C right here? So remember, think about that as a transversal. Like if that went, don't really have a highlighter, but if this kept going this way and this kept going this way, okay? What would happen? What are those two angles right there? Okay, so this angle here is going to be congruent to that angle C because those are corresponding angles. Remember, they are the same. So angle B, A, and C is going to be equivalent to E, C, and D by corresponding angles. Okay, so what do I have? I have an angle, angle, and a side. Angle, angle, and a side. So that means that triangle, if I go the other way, A, B, and C, so triangle A, B, and C is going to be congruent to C, E, and D. Remember, you have to start with the same sides and angles that are congruent to each other. Okay? And so that's an angle, angle, side, angle, angle, side there, angle, angle, side. So that would be by angle, angle, side. Okay? All right, y'all try number 6, and I'm going to let you do number 5 on your own. So we're not going to go through number 5, but we will go through number 6 together. So try number 6. Okay, so here I have LG is going to be parallel to JM. So LG is parallel to JM. Okay, so that was given. Also, H is midpoint of LM. So that's given. All right, so what does that mean? So H is the midpoint of LM. So that means that these two sides are going to be congruent there, right? So that means that side LH is going to be congruent to side LH. All right, so if these two sides are parallel, okay, here is my transversal. So that means that this angle and this angle are going to be congruent, okay, by alternate interior angles. So remember, if you kept drawing your parallel lines right there, okay, and this was your transversal, okay, then those two angles are alternate interior angles. So angle, sorry, now I can't read that. So L, G, and H, and angle M, J, and H. Okay, and then what is H right here? So those are vertical angles right there, so those are going to be congruent. So that means what? L, H, and G, or well, let's go the other way. So angle G, H, and L. Okay, so G, H, and L is going to be congruent to J, H, and L. Okay, because those are vertical. All right, and I'm going to do some different colors. Well, okay. So now I have an angle, angle, side, angle, angle, side. So those triangles are going to be congruent. So triangle L, G, and H is going to be congruent to M, J, and H by angle, angle, side. Okay? All right. So there's one more type of proof that we're going to do, and this is a hypotenuse. It's a right triangle. Okay, so I guess what's this one? My third one? Okay. And we call this one HL. We call it the hypotenuse leg. Okay, if the hypotenuse and a leg of one right triangle is congruent to the hypotenuse and a leg of another right triangle. So what's happening here? This is not just a normal triangle. Now what's special about this is my triangles are going to be right triangles. Okay, to another leg of a right triangle. What is that? What is that word right there? Triangle. Okay, then the triangles are congruent. Are congruent. All right, so what's special about this one is I'm going to have two right triangles. Okay, so we'll say A, B, C. Well, that's D, E, and F. Okay, so if we have a right triangle, right? So here, if we have a right triangle, number one. Number two, if side BC is congruent to EF there, because that's my hypotenuse, right? So if side BC is congruent to side EF, okay, and side AB is congruent to DE, then the triangles are going to be congruent, okay? So then triangles ABC is congruent to triangle D, E, and F. Okay, so hypotenuse is always the opposite of the right angle there. So the hypotenuse is always across from that right angle. Okay? All right, so let's do these. There's two in here. Okay, so, all right, let's look at this one. So, given that triangle LMP and triangle MNP are right triangles. So that means that LMP and MNP are right. Oh, I'm sorry, I went the wrong way. LMP and MNP. Okay, are right triangles. So if, well, that's a triangle. LMP and triangle MNP are right. Okay, so that's given. So we're so far so good. So that's given. So down here is my right angle on both sides there. So that means that ML is going to be also congruent to MN. That was given to us as well. So ML is congruent to MN. So that is my hypotenuse, right? Okay, so my hypotenuses are congruent. So now what do I have right here? So by the reflexive property, MP right there, that's going to be congruent. So MP is going to be congruent to MP by the reflexive. Okay, good. All right, so I have my hypotenuse and I have a leg that are going to be congruent. So that means that triangle LM and P is going to be congruent to NM and P. And the reason behind it is because it's a hypotenuse and a leg. Okay? All right, so y'all try to do number 8 here for me. Okay, so triangle W, V, and X. So W, V, and X. Okay, and Y, Z, and X are right triangles. Okay, so they're right triangles, so that means that down there, those are where my right angles are going to be. WV is going to be congruent to YZ. So WV is going to be congruent to YZ here. YZ. Okay, so that was given. Okay. Also, X is the midpoint. So X is the midpoint of WY. Okay, so if it's the midpoint, so then that means that these two sides are going to be congruent. So WX is going to be congruent to YX there by definition of a midpoint. Okay, so that midpoint side there is across from the right angle. So that is my hypotenuse, right? So I have a hypotenuse and I have one leg. I have this hypotenuse and I have a leg. So I have a congruent hypotenuse and I have a congruent leg. So that means that these triangles are going to be congruent. So WVX is going to be congruent to YZX. Okay, good deal. All right, so do the homework on this section, and tomorrow we'll review everything, all the different types of triangles proofs, and then we'll do one more on Wednesday. Okay, y'all have a good day.